So now let's look at causes of refraction. What brings about the change in direction of light, and then we should talk about that in terms of speed of light. So if they ask you to explain the causes of refraction in terms of speed of light, what can you say? We can say the bending of light rays is as a result of change in speed of light as it travels from one medium to another of different optical densities. Okay? So the reason why light changes direction, it is basically because there is change in speed. Okay? That light has different speed in different medium. And why is it having different speed? It is because different mediums have different densities. So it is the density that is affecting the speed of light. And if the speed of light changes for every medium, it means that even the direction will change, and that is basically what we're calling bending of light rays, generally known as refraction of light, as earlier on defined. Okay, so the reason why light changes direction, it is because the speed changes. And the reason why the speed changes, it is because as it's moving from one media to another, the densities of the media also changes. So that is what is basically bringing about refraction. And we have just talked about it in terms of speed of light. So we can add on and say the change in speed results into change in direction unless the ray is incident normally. Okay, so always it's very true that the change in speed, it is known that it will always cause change in direction. Otherwise, or else, if and only if the rays are incident normally, because we know that if the rays are incident normally on the surface, it will not change direction. What am I talking about? If I have this, if the rays are incident normally like this, it will not change direction. Okay? It is not going to change direction. The change in direction only appears if the ray is incident at some angle. Okay? So that is basically what will bring us to the change in direction, that the rays must not be incident normally. If it is incident normally, even if it changes the media, it is not going to change direction. And we can also say that the speed of light is greater in vacuum than in water or glass. And this means that, or this is because the density of water and glass is greater than the density of vacuum. Okay? So, the reason why we are saying that light moves at a very high speed when it is in air than in water, it is because air is less dense than water or glass is more dense. The density is greater than the density of air. Please don't forget that if the density is very high, the speed also becomes less. Okay? And if the density is less, the speed is very high. And this is all about the causes of refraction in terms of speed of light. You can also note this. You can also note that if the light rays travels from less dense to more dense medium, it's refracted. If the light rays travels from less dense to more dense medium, it's refracted towards the normal. Okay? Towards the normal line. Illustration could be, if I have this, if I have something like this, if this is my normal, if I have light rays moving from air, if it is, we are taking air to be the less dense one, from less dense, that is air, angle of incidence, what is very true that this light will bend towards the normal. You see, the real direction of this light is supposed to be this. If it was to proceed, it would be this. Okay? Now, this side here is towards normal, and then this other side here is away from normal. So this line here divides everything. That if it comes this side, then we say towards normal. If it goes on the other upper side, we say away from normal. So we are saying it moves towards the normal. That means that it will come this side as R, and this is now our glass. That is on a condition that it is moving from a less dense media to a more dense media. So therefore we say the light will travel, will always diverge towards the normal. And then two, if the light travels, if the light rays travels from more dense to a less dense medium, the refracted, it's refracted away from the normal. Okay? So here we are saying that in a scenario where we have something like this, if this is my air and this is my glass, if the light rays is coming from glass, this is angle of incidence. So we are saying that if we have this line here that is supposed to divide it, this direction here is towards the normal, because normal is here at this side, and then this one is away from the normal. This is away from the normal. So we are saying that it will always move away from the normal, and that means that it will instead move this other direction, and then our angle will be this as a I. Okay? That is what we are actually talking about, because as it's traveling from more dense media to less dense, the speed will therefore increase, and from here the speed will therefore reduce. Okay? And then lastly, We can also say that if the light ray is incident normally on the interface, it's not refracted at all. That should the light rays come when it is perpendicular, what is very true is that there is going to be no refraction, or there is going to be no change in direction. And that's what we're saying, that if we have something like this and the light rays comes when it is 90, it will not change direction. Instead, it will move along with the same path, in the same direction. Okay, so these are some of the basic things that should be helping us when we are going to be analyzing our numerous examples.